Hello everyone, welcome to the next lecture on the June 2023 mathematics solution. Today we will discuss about real analysis related to the sequence and series. Myself Dr. Harish Garg. You can simply follow my YouTube channel and you can scan and join my WhatsApp group here. What you will be found on my YouTube channel, we have already discussed the previous year's June 2023 papers related to the integral equation, LPP quotient, ordinary differential, Markov chain. Almost each topic we have covered in my this YouTube channel playlist CSIR UGC net. You can follow my YouTube channel and subscribe my channel. So let's start with this video. So remember that whenever there is a question related to the net examinations or gate examination, you have to read the statement very carefully. So remember, there is a one word which can discard the option, one word which can accept the option. So you always read the statement very carefully. So now look at that. The first statement is xn is the sequence of the positive real number. This is the most important line. If sigma n is the average of this, then which of the following statement are my true? If limit supremum of the xn is my L and xn is my decreasing sequence, then limit supremum is also n. So do you think that what is this series? What is this sequence? If you know, yes, this is a very famous result called as the Cauchy first theorem on the limit. What is the Cauchy first theorem the limit said? He said if xn is the sequence which converges to the L, then the average of this sequence is also converges to the L. However, there is no condition on the xn. The only condition is xn is my positive real numbers. But here this is a decreasing sequence, that is additional statement which is not necessary that whether it's increasing or decreasing, its result is applicable here. So this is my correct statement. We also know the converse of this statement is not true. We also know the converse of this xn is a real number. Xn is a sequence of the real number. But we all know the sequence converse is not true, and famous example is my here. But this example is not applicable to be in this case because it's a positive real number. So what you can think about that? That's a very simple again. You can think about any of the positive sequence. We know this is the counter example for the positive sequence. How you can make this sequence to the positive real number? It's a plus 1 and minus 1. So if I add this as here, fine. What is that? This always be the positive sequence. So what is that? It is 3 and 1 depending upon that whether n is even or n is my odd. Then what is the limit supremum of xn? Limit supremum of xn is my 3. Fine. Now if I prove that sigma n limit is also 3, then this is also the correct option. Now what is the sigma n? This is x1 plus up to the xn over n. So we all know what is the limit of the sigma n. We can take the average of this. 3 plus 1 over 2, that is my 2 is the limit, and you can see both are not same. But anyhow, how you can prove? Again, if n is even, so if n is even, it will be half of the odd. Odd is my 1, half of the my even. Fine. And when n is my odd, what will happen? Half of them is my even, but half plus 1 will be my odd series. Fine. Now you can take the limit as 1 by n also. So what is that? This is 2n by n. This is my 2. This is my 2 plus 1 by n. This is my even and this is odd. Now you can take the limit as n approaches infinity. This will be by 2 and 2. So what is the limit supremum of this? Is 2. This is my 3, which are not equal. So that's the if and only if is not satisfied. A very simple thinking about that. Why I consider this example? Because we all know Cauchy first theorem converse is not true for this sequence. But it's a positive sequence, so you can make them as a positive sequence. Either you can add 2, you can add 3 and so on. If you don't want to calculate like of this manner, we all know if this are the 3 and 2, take the average of this, it will be my sigma n is my 2. If you consider this as 4 plus minus 1 of n, then it will be my 5 and 3. Take the average of this, it will be my sigma of n. Anyhow, so this is over. Now look at this rest two parts. Now if you think about what is that, what is this series, what is this? This is nothing but my rabies test. Fine. So when the rabies test convergent, if I consider when this is greater than 1, it's a convergent. Divergent when it is a less than 1. But here you can see less than 1 is a divergent. That's a correct option. This is cancel out. But look at the another side. What will happen if you don't remember that whether it's a rabies test, logarithm test, or any test are there? Then how you can approach in the examination? It may possible that you can't remember this is a rabies test. Then think about any of the sequence which is already a divergent. Say 1 by root n. You all knows this is a sequence. This is the if I consider a series as my here. Fine. So this is by the p test. This is my divergent. Fine. Now if I substitute here, what will happen? This is 1 by root n. This is 1 over n plus 1 minus 1. So what will happen here? We will check whether it's a divergent again by this rule or not. Here. Fine. So if I take the LCM, what will happen? This is n plus 1 minus of this is a n by root n is my here. Now you can rationalize them and then you can see what will happen. This is n plus 1 here. Now as n approaches infinity, this will be 1 by 2, which is less than 1. Hence it satisfied this condition. So but this series is my divergent. So hence this is again the correct option. Moreover, if you consider some another example, like I can written like of here, say 1 by n square. We all know this is my convergent by the p test. So if I substitute here, this is n plus over n square minus 1. So if I take LCM and if I open them, n square will be cancelled, 1 plus 2n. So 1n will be cancelled out. 1 by n plus 2. As n approaches infinity, this will be 2, which is greater than 1. But all the cases are my less than 1. So it means this is a convergent, but this convergent is greater than 1. So again, this option is cancelled out. So that's the way you can approach this question, easy manner. Okay, look at this next question. Xn fx is my 1 by 4 plus x square. x0 is given to you a and xn is defined to be my here. So firstly we can define the xn. So 1 by 4 xn minus 1 is a minus xn minus 1 whole square. Then which of the following is true? If a is 0, then sequence converges. What is the definition of the sequence convergent? If this limit is my finite and unique, then you will get as a sequence is convergent. So you take the limit L on the both side, plus L minus L square. So what will happen? L is my plus minus 1 by 2. It means this sequence convergent either to the plus 1 by 2 or minus 1 by 2. How you decide whether it's a plus 1 or minus 1? Look at the first term, either x0. If it is a positive, then it converges to the positive. If this is a negative, then we consider as this convergent negative. So what is the x0? x0 is my a. So look at the first part. A is my 0. So a0 is neither a positive nor a negative. So we will try to find the x1. What is the x1 from here? 1 by 4 x0 minus x0 square. x0 is a is my 0 in the first case. So this is 1 by 4, which is greater than 0. It means this sequence converges to the positive limit. So what is the limit I have obtained is 1 by 2. This is 1 by 2 is a positive, is the right answer. Last option is a0 sequence does not converge, is cancel out. A is equal to 0 convergent to minus 1, cancel out. Look at that. When a is equal to 0, a0 lies here. Now, but we can't say that whether a is equal to, now a0 is convergent when a0 lies here, and convergent to the plus 1 by 2 is again the right option of this case. Moreover, if I simply take a is 1 in this case, so a is 1, then a is 1, that's a positive, then its convergence to the here. So again, because a is 0 is a positive, so 0 is lies here, is a positive sequence convergent to the plus 1 by 2. 1 and the third are my correct option. Okay, look at this another one. That is a transformation of the canonical form. Very simple about that. I already gave you various tips how you can solve them. You can take the Jacobian of this P and Q and it is 1. This is the condition for the canonical. Fine. Or it's on your choice whether you want to write capital Q firstly, then denominator is also P firstly. If you take as a capital Q, then it's a small q, P or P. It's on your choice. So for example, if I write in this case, what will happen? Capital Q, this here, this is P, or you can say it's a Q or P with respect to Q and P with respect to small p. That's on your choice. So this is one given to you. Now what is the capital Q? What is the derivative with respect to Q? P times a plus 1 of Q. Q with respect to P, Q times a plus 1. P with respect to Q, B, Q of B minus 1. P with respect to P is a 0. So what is the determinant of this? You can see it's a minus B Q raised to power a plus B is 1. When it will be 1? The first condition fails to satisfy. Second condition fails to satisfy because B is 1. Third condition again failed to satisfy. Fourth condition is the only option which satisfies this property. Right answer is my fourth is the correct option. Okay, look at this another one. Which of the following condition implies the sequence is my convergent? So we can check about the, look at the first option, last option. If I consider here, what is my limit of this? This is n plus 1 minus of this. What is that? This is limit 1 over n plus 1 which goes to the 0. It satisfied this condition, but this is my divergent. But the given question asks that which of the following condition implies sequence is convergent. This option is cancelled. Look at the first case. Xn has a subsequence of 2n, 2n plus 1 and 3n. So it consists of all those even numbers, it consists of all those odd numbers, it consists of the multiple of the 3. Now they all have the same convergent. So it means as n approaches infinity, this subsequence convergent to the L, they have the same limit. It means they also convergence to the same 2n plus 1 and they also convergent to the same limit as of 3n. Now look at that, whatever the xn sequence is there, x1, x2 up to here, you can pick any of this number, any of the sequence. Let's say x9. So x9 is a odd, has a limit L, is a multiple of 3, again limit has a L. If I consider x11 is a odd, limit L. If I consider 2020, it's a even, it has a limit L. So each part has convergent to the L and this limit is my unique. So it means if all have the same limit, then it has a sequence is convergent. Look at the second option. The subsequence, these are convergent. Now in this case it is not given to you that they are convergent to the same limit. So it is L1, second limit 2n plus 1 I consider as a L2, and the third limit I consider as L3. Now whether L1 is L2 is L3 or not, it is not given to you. Fine. Then you have to check whether it's a convergent or not. How you can check the convergent? If I prove that each of the terms occurring in this sequence is convergent to the unique limit. Now look at that. If I consider any of the odd series, this part, fine, it always convergent to the L2, that's the same limit. But if I consider say x9, which is an odd number, also it is a multiple of the 3n. So but it has a convergent, it is given that it has a convergent. It means xn corresponding to the odd limit has a L2, it has corresponding to 3 is a L3, but it is given that it's a convergent. It means it has a unique limit. So what is the meaning of that? L2 is equal to L3. Fine. Similarly, if I consider as x6, again, this is my even series, even number, as well as of the multiple of the 3. And this is my convergent. When it's said to be the convergent, when the limits are my same. So corresponding to the 3n, the limit is my L3. Corresponding to the even number, limit is my L1. So it means L1 is L3 also. So from these two cases, we can say L1, L2 and L3 are same. That is same as of the previous case. So which is also the correct state. Remember, this word is important. If this is not given to you, for example here, then definitely it is not a convergent. Why? Because if I take x9, it convergent to the L2, x6 convergent to the L1. Both may or may not be the same. So that's why this x3 is the most important word. That's why this is also the correct statement. Now look at the third option, whether this is a correct or wrong. The subsequence xk is, that is x2n, x3n, x4n and so on. Whether these are my convergent sequences. So if I say this is convergent to the L1, this is L2, this is L3 and so on. So what kind of the numbers are there? 2, 3, 4, 5, so on. So if I consider this is my sequence as here, if k is my prime number, then consider as a 0, and k is not prime, that is called as the composite number, then it's a 1. Then clearly says the sequence like of the 2n is a prime number, 3n is a prime number, 5n, 11n, 13 and so on, they are convergent to the 0, and the rest of them like of the 4n, 6n, 9n, and they are convergent to the 1. So it means this is my convergent. Fine. But you can see what is the limit of 9. This is not a prime number, or you can say limit x of 2n plus 1. Is it always give a unique limit? No. If I consider n is my 1, it give you x3. x3 is my odd, so is a prime, so it give you a 0. When I consider n is my say 4, it is 4 to your 8, 9. 9 is a composite number, it goes to the 1. You can see corresponding to the single sequence, we have the two different limits. So limit is not unique. So once the limit is not unique, it means this is not convergent. So this option is cancelled. That's a very interesting question, because look at that, there is a difference between them. These are all even, all odd, multiple of the 3 only. But here the multiple of the 5 also, multiple of the 4 also, multiple of the 7 also, which is not covered in this case. So that's why they are not a convergent. Okay, look at this one. So why I consider this question in here? Everybody said this statement is a wrong, but I said this statement is a correct statement. Look at that. If I consider here, by using the Leibniz test, what is the Leibniz test? This is my here. If you prove that an is my decreasing, an goes to the 0, then this series is my convergent. And clearly says this, if you rationalize them, you will get here, which is a decreasing because the derivative is a negative. It goes to the 0 as n approaches infinity. So this is my divergent. But this question is a part B. Fine. This is a part B. So this is a but there is another option about the conditional convergent and absolute convergent. So if I take the modulus of this, what is the modulus of this? This is my modulus. Fine. If I call this as my say u of n. So if I rationalize them, it will be here. Now if I consider the Vn is my 1 by root n. So what is the un over Vn? It goes to the half as n approaches. So it means this is my finite. But we all know this is my divergent series by p test. So it means this is not absolute convergent. So what is the meaning of that? It is already a convergent. It is not absolute convergent. It is not absolute convergent. It means this is my conditional convergent. Now you can see that there are the two correct options given in the here, but this is the question related to the part B. Now which one is the correct option? Think about that. If I simply say here, is this, what is the behavior of this? This is a absolute convergent. Absolute convergent implies convergent. Fine. Now look at that. So what you say, you always said it's absolute convergent, but here this is not a absolute convergent. So it means this is a convergent, but the conditional convergent is a more stronger condition than the convergent. So whenever you think about the conditional convergent and convergent, you can't say that it's a convergent, because this is the convergent plus conditional is another thing. So this is the most appropriate answer of this question. So this is the wrong option, and this is third is the correct option of this example. Look at this another one. Consider the two sequence, whether the sequence an is here. Again, purpose is similar. Your target is to prove this is my finite limit and unique. Then you can say it's a convergent. So what is that? If I start from here, limit an as n approaches. So how you can put the limit? So I can return this term as in terms of the summation n plus k. K varies from 1 to n. So remember, what is the tips I always gave to you? Whenever there is a question of the limit and question of the summation, you always try to convert into 1 by n form. So how you can make them? I can simply take 1 over n as a common. So this is 1 plus k over n. Now I can substitute k by n is my x. So 1 over n dk is my dx. Dk is, this is the limit from k1 to n as n approaches infinity. So this is 1 over 1 plus x of dx. When k is equal to 1, the x value is 1 by n, and n approaches infinity is a 0. When it's a 1, it is my 1. So what is that? This is log of 1 plus x 0 to 1 to the base e, that is log of 2. So it means this is a finite. This is a finite. So it means an is my convergent to log of 2. So last option is cancelled. This option is also cancelled. Rest of the part said it's the same rate of the convergence that of the Bn. Firstly, we will check about the limit of the Bn. What is the limit as approaches here? This is 0, which is also finite. Fine. So it means an and Bn both are convergent sequences. Fine. Now once they are convergent, then your target is to find the rate of the convergence. So how you find the rate of convergence? That is very simple. You can use the numerical analysis concept. Like if you sequence an, it converges to the L, then your target is to prove this of any sequence, say gamma of n, any of the sequence. So where k is my any real numbers, this is my sequence, then it has the rate of the convergence as of order of gamma of n. Now you get that for the an is my 1 over n plus 1, 1 over 2n, L is my ln of 2. Because of this negative sign, I can return this as less than of n plus 1, n plus 2 up to n plus n. Again, because n plus 1, I can return this in terms of the Bn is 1 by n up to 1 by n. So what is that? This is 1. So k is my 1. I can consider this as a constant sequence. So what is that? What is that? This an, the rate of the convergence of the an is my order of 1, or you can say 1. Similarly, you can find the rate of the convergence of the Bn. What is the B? Is 1 by n. L is my 0 because it converges 0. So 1 by L is always be less than of the 1. So you can see both have the same rate of the convergence of order 1. So it does not have the same rate of convergence. Cancel option. The first option is the correct option of this example. Okay, look at this another one, which is a uniform sequence of the function. What is the condition for the sequence of the convergent? Sequence of the function, you always need to prove firstly it's a piecewise continuous function. If the function is not a piecewise continuous, then it is not a uniform convergent. But if the function is a uniform convergent, it is always be a piecewise continuous. Now look at that. Firstly, we will check about the piecewise continuity. What is the condition is? Limit n approaches infinity. If I say this limit exists, then you can say it's a piecewise function. Continuous, if the limit of this fx is also exists, then we can say it's a continuous. Firstly, we can take the limit of this. What is that? Limit xn as n approaches infinity, x belongs to the 0, 1. So it will goes to the 0. This goes to the 0. So this is a finite. This goes to the 0. This goes to the 0. It's a 0, 0 and 0. So all the functions are my piecewise continuous. Fine. So that's fine. Now, how you can apply the uniform convergence? So you have to apply the MN test. That is, you have to check Fn minus f goes to the 0 as n approaches infinity. Fine. Then you can say it's a uniform convergent. If it does not goes to the 0, then it is not uniform convergent. Fine. Now look at the very simple. F is always 0 in this case. So your target is to prove this will goes to the 0. First example, first case, that is your target is to prove this will be here. So you can take any of the subsequence or any of the sequence from here. So it's a 0. You can take either as a 0 plus 1 by n, or you can take 1 over here. So if I take this as 1 minus of this, what is that? As n approaches infinity, it goes to the e raised to power minus 1, which is not 0. Which is not 0. What is the meaning of that? It is not uniform convergent. First option is cancelled out. So what is the meaning of that? The sequence x of n, the function fn is, the function fn is xn is not uniform convergent. So look at the same example for here. If I consider the same example here, the numerator will be e raised to power minus 1. Denominator will be here. Again, it will not goes to the 0. It is not uniform convergent. Look at this example. This part will be e raised to power minus 1 plus n e raised to power minus 1. Now as n approaches infinity, it goes to the 0. So it means this is a uniform convergent, but he said not. So this option also cancelled. Only the correct option is my 2 is the right answer. How? You can see that for the second option, the numerator is e raised to power minus 1. Denominator is here. So as n approaches infinity, it goes to 0. So therefore, it is my uniform convergent. So the right answer is my 2 is the only correct option. So I hope you can simply learn the various tricks here. So we will see the next lecture soon. Till then, you can simply like, share and comment on my video. Best of luck, students. Happy learning always.